7.2. Now we're going to be multiplying and dividing rational expressions. This is multiplying and dividing fractions. Only thing is that these fractions now have variables. So we need to review back our fraction rules. Well, multiplying, dividing fractions. When we multiply fractions, it's numerator times numerator, denominator times denominator. But I've told you, don't multiply first. Always divide before you multiply. The reason is it's going to make it smaller here. It's also going to make it a lot easier when we now get into the expressions. So this is where the Haya method really takes off. Can I reduce within this fraction, the 12 over 10? Yeah, so I'm going to start reducing within it. So what can I divide the 12 and the 10 by? I can divide each of them by 4, 3, 2. There we go. Divided by 2. Gives me 6. Gives me 5. And now I've gone as far as I can go in this one. So now I can start going across into the other fraction as well. This will only happen when it's multiplied. I can only go into the second fraction if I'm multiplying. Nothing else, not dividing, not subtracting, not adding. Only multiplying. So now I look, oh, I've got a 5 and 5. I can divide 5 by 5, get 1. I can divide 5 by 5 and get 1. I can also look at the 6 and the 4. I can divide each of those by 2 again. 6 divided by 2 gives me 3. 4 divided by 2 gives me 2. So I'm left with 3 over 2. Takes me to the simplest form right there in one step when I Haya right at the beginning. Dividing fractions now. Two different methods that you learned all the way back in grade 8. That's where we actually learned this. Two different methods. One method would be to take the second, or take them to a common denominator, and then you can just divide the numerators. Second method was multiply by the reciprocal. And that's the one I'm going to focus on here because that one tends to be the quickest and easiest. So we've got negative 3 over 5 multiplied by the reciprocal of the second one, 20 over 3. Now I can start Hayaing and see what I can take out of each fraction. Can I reduce within the first fraction? No. Can I reduce within the second? No. But I can reduce through each of them. I can take out a 3 here, give me a negative 1. Take a 3 out of here, get a 1. Okay, and we can go into the second fractions here. I can divide each of these by 5, which gives me 5 divided by 5 is 1. 20 divided by 5 is 4. Now I just multiply numerator times numerator, denominator times denominator, which gives me negative 1 times 4 is negative 4, and 1 times 1 over 1, which is just negative 4. Let's look at this next one. Negative 1/6 divided by negative 8 over 24. First move, multiply by the reciprocal. See if I can reduce within the fraction first. First one can't reduce. Second one, yeah, I can reduce within there. I'm going to divide them each by 8. So divide this by 8, gives me 3. Divide this by 8, it's going to give me negative 1. I've got a negative 1, I've got a negative 1. I can take those and divide them into a positive 1. I've also got a 3 and a 6. One has to be numerator, one has to be denominator. The only way we can go into the other fraction if it's multiplying. I couldn't start going in between fractions until I've got the multiplying. And I can divide the 6 by 3, get 2. Divide the 3 by 3, get 1. I'm left with 1/2. There's your lowest terms fraction done right through there. let's now apply this exact same process if we have x's. We're just going to use the hiya all the way through here. So let's start with the first one. We've got x over 3 times 3x over 4. We're multiplying, so I can try to reduce within the fraction. Nothing can reduce here, nothing can reduce there. But now I can start going into opposite fractions. Well, I'm able to hiya the 3's. 3 divided by 3 is 1, 1. And that's as far as I can go. So my answer now is x squared, x times x, over 1 times 4, x squared over 4. But I have to look. Do I have any NPVs? Got to remember the NPVs from 7.1. And there's no variable in the denominator, so therefore there's no NPV. It's just x squared over 4. Next one. 3 over x divided by 5 over x. Actually, you know what? I'm going to do this one first, just because it's multiplying. Negative 2 over x times x squared over 5. Let's do that one first. Can't reduce within the first, can't reduce within the second, but now I got multiplying. Because I have multiplying, I can start going in between the fractions. Can't do the negative 2 and the 5, but I can do the x's. That x goes to 1. This x squared goes just to x. It's the same thing as you learned last year with your exponent laws. Subtract the exponents. X squared, 2 minus 1, leaves you with an x. So now I have negative 2x over 5. But I've got to look at, do I have any NPVs in the denominator? Well, there was an x in the denominator before I canceled it off. So therefore, x cannot equal 0. There's your final answer. Let's go to the next one in line there, the next multiplier. So now we've got negative 2 over x plus 1 times x plus 1 over negative 8x. Can't reduce within the fractions. And I'm going to tell you right now, whenever you have binomials, always think of it as brackets. Really, any numerator and any denominator has brackets around it. So let's look at here. We've got a negative 2 and a negative 8. I can divide those both by negative 2. Negative 2 divided by negative 2 is 1. Negative 8 divided by negative 2 is 4. You can't cancel off these x's. This is surrounded. It's a package. When there's adding and subtracting, it has to go as a package. You can only cancel off a whole package or nothing. So if there's adding and subtracting, there's brackets around it, that's together, it goes as a package. But I do have the same package numerator and denominator. I can cancel those two off. That goes to 1, that goes to 1. This is now leaving me with 1 times 1 and 1 times 4x. So my answer is 1 over 4x. Okay, and now I have to look at the NPVs. Anytime you have a variable in the denominator, you're going to have to deal with an NPV from there. So, first one, I've got negative 8x. That means that x cannot equal 0, because that would make this denominator 0. But I've also got an x in this denominator. What value is going to make this denominator 0? A negative 1. So I've got x cannot equal 0 and negative 1. Now the dividing ones. So 3 over x divided by 5 over x. We'll start there. Multiply by the reciprocal. Multiplied by x over 5. Now I can start reducing. Can't reduce within this fraction, can't reduce within that fraction, can't reduce the 3 and the 5, but I can reduce those two. So I'm left with 3 over 5. But I've had x's, and I had x's in the denominator. Look at all of the denominators. There's a denominator, there's a denominator, there's a denominator. There are actually 3 different denominators. And you have to take the NPVs of each one of those. So this one here, x cannot equal 0. No. So x cannot equal 0 from that first one. This one here, which is also a denominator, x cannot equal 0. Got it already. And this one's 5. There's no variable. So there's my work. Let's try the next one. Negative 2 over x divided by negative 9 over x squared. Pause it now, try it, and then replay. Okay. Negative 2 over x multiplied by the reciprocal, x squared over negative 9. And then start seeing what we can work with. I got a negative and a negative. I can make those positive. I've got an x and an x squared. That'll go to 1. This will go to x to the 1. So now I'm left with 2x over 9. But I had denominators. Let's look at all of the denominators. That was a denominator, that was a denominator, and that was a denominator. There's 3 denominators. X cannot equal 0 for the first one. Second one's x cannot equal 0. Third one doesn't have anything, so we don't have to worry about it. X cannot equal 0. And now last one. Again, pause it, and then try it yourself, and then replay. So let's multiply by the reciprocal. Multiplied by 20x over 2x plus 2. Okay, so let's look at what we've got here. Can't do anything within. You cannot take out that x in the first fraction. The numerators, a package, the denominators, and the numerator, that denominator already has 1. So here we go. We've got an x plus 2 and an x plus 2. That can go, it can only go when we've got multiplying. So that x plus 2 and that x plus 2 cancels off to 1. Now we go further. I've got an x here and an x there. There's no adding or subtracting within those, so I can cancel off those x's. They do divide off. Now I've got a 20 and a 5. Divide each of those by 5. That leaves me with 4 here. But then I got a 4 and a 2. I can keep going further. Go to a different color so you can see. Divide that, gives me 2. Divide that, gives me 1. All of this mess goes right down, and all we have left is 2. But NPVs. Every fraction, or sorry, every denominator we have to look at. There's a denominator, which is this one still. There's a denominator, but this one was also the denominator. We've got 3 denominators when we're dividing that we have to look at. The first denominator, 5x, that means that x cannot equal 0. This denominator is also x cannot equal 0. But this one, we have x plus 2. I can't put a negative 2 into that one. There's your full work. Okay. Let's simplify each expression. So let's take the first one. Put that over there for now. Well, can I reduce within the fractions? No, neither of them. It's multiplying. Can I reduce between the fractions? Well, yeah. This one, I've got an a and an a squared. So I can take that down to just a to the 1. But I also have a 9 and a 3. I can divide that by 3, gives me a 1. Divide that by 3, gives me a 3. And we get left with 2b squared over 3 times the 5 gives me 15a. But we also have to remember the NPVs. Even if they don't ask you, what are the NPVs? You still have to put it down. What was in the denominators? Well, this one only had an a in the denominator all the way through, so a cannot equal 0. There's no plus or minus there. Let's jump to the next one. We're multiplying. Applying what we know. So, do I have any packages that are the same? Yeah, x plus 2 and x plus 2. Those ones can cancel off. Let's look further. I have an x squared here and I have an x. That's going to divide off to x. That to 1. Oh, but I have another x. I can divide that one to 1 and that one to 1. Oh, look it. I've got a 2 and an 8. I can divide that one by 2 and get 1. I can divide this by 2 and get 4. So let's bring everything together, what I have left after all that junk. Cancels off, gone, gone, gone. The whole numerator is gone to 1. It's not that it just vanishes to 0. It's still equal to 1. That whole numerator is 1. So now we've got just 5x minus 4. 5x minus 4 over 3 times the 4. That's all that's left in the denominator. 12. Comma. Got to do all of our NPVs. This part and that denominator. First part of the denominator, x cannot be equal to 0. Second part, we've got an x here, which cannot be equal to 0. We've already got that one. And an x plus 2, so negative 2. That's the final answer on that one. All right, number 2. We've got dividing, so we're going to multiply by the reciprocal. 7n cubed over 4 multiplied by negative 12 over 7n squared. Now we can start looking to go further. Well, 7n in brackets squared. That's not 7n squared. I actually have to apply that squared to both of them first before I do anything. That's 49n squared. Now I can start looking at canceling off. We got 7 in the numerator, we got 49 there. Hiya, 1, 7. I got a 4 and I got a negative 12. Hiya, 1. Hiya, negative 3. Now I've got the n's to deal with. N cubed and n squared. Well, I can take 2 of them off of there. I can take 2 of them off of there and just left with an n. Collect what I have left. What's in the numerator still? negative 3n over, what's in the denominator still? 7. But, comma, we need to still do our NPVs. NPVs, remember, are all of the denominators. There was a denominator, there was a denominator. No NPVs in those ones, but this denominator we also have to look at. So n cannot equal 0. Alrighty, so probably a good idea to try to pause, try it yourself, see if you get the right answer. So, start by flipping, taking the reciprocal of the second fraction. And now let's look at, it might be a good idea to do your NPVs right off the bat here before you start crossing off and you start losing them. Your NPVs, here's a denominator, there's a denominator, there's a denominator. The 3 denominators you have to look at. So let's do our NPVs right off the bat and just say x cannot equal 0 from the first one, x cannot equal 0 from this part, x cannot equal negative 5 from this part, and x cannot equal positive 3 from that part. And then now let's start hacking it up. X minus 3, boom. X minus 3, boom. X, and the 5 and the 10 goes to 2. And that's what we're left with now. So we've got 3 bracket x plus 5 over 2 times 2, so 4. Comma, don't forget to throw this NPV down right after it. X cannot equal 0, negative 5, and 3. The NPVs from the original question have to be the NPVs of the answer because we've said that they are equal. And last question here. This is where factoring starts coming into play. We've got 1, 2, 3, 4 parts that need to be factored in this one question before we can even start doing much. So let's factor the numerator. And this is why you want to have practiced up all your factoring so that you can factor this quickly and say, oh, that's x plus 4 and x plus 5. Over. This you want factored, you're going to factor out a 2. And then you've got x squared plus 3x minus 4. And then when we factor that, we get x plus 4 and x minus 1. Then we've got a difference of squares on that numerator. X minus 1, x plus 1. And then we've got just a GCF to factor out of that one. 3 bracket x plus 5. And now the fun begins. We get to hiya these ones and it feels great. So we look at x plus 4, bye-bye, baby. X plus 3, or sorry, x plus 5 gone. X minus 1 gone. Whole package or nothing at all. And what do we get left with? Numerator is just x plus 1. Denominator is just a 2 times a 3, so 6. But now here's the hard part. We got to do any of the NPVs. Any place that there's an x in the denominator. X plus 4, so that means x cannot equal negative 4. X cannot equal positive 1. X cannot equal negative 5. It's always a good idea to write those in an order. Descending order is probably ascending order is probably the best, going from smallest to largest. Not that it's a big deal, not that you'll get it marked wrong, but I'm just going to change that just to put it into the order that you'll see. Again, order doesn't really matter that much. And done. again, I highly recommend you pause this one and then try it and see if you can get it on your own. Here we go. Multiplied by the reciprocal. Factor it. You could either factor to start and then multiply by reciprocal, or multiply reciprocal and then factor. Either way doesn't really matter. So let's factor them now. First one is already factored. Second one we can take out a 3, x minus 7, multiplied by this one. We can pull out a 3. And then when we factor that all up, x minus 7, x plus 3, we'll get lots of practice factoring all the way through. This one, when we pull out the 3, we actually get x squared minus 4, which is a difference of squares. This one here, when we pulled out the 3, we got left with x squared minus 4x minus 21. So factoring the x squared minus 4, difference of squares, we get 3 bracket x plus 2, x minus 2. And now because we're multiplying at this point, we can start crossing off. I'm going to look at it and do my NPVs, just look at which ones I have to worry about now, because I don't want to forget and miss one of them that I canceled off. Have to worry about this denominator, have to worry about this denominator, but this numerator here was the denominator up here. So I'm going to have to worry about that one as well, because it was a denominator at one point. Okay, let's start canceling off. I got x minus 2's divide to 1, x minus 7's divide to 1, 3's divide to 1, and that's what I've got left now. We've got x plus 3 over 3 bracket x plus 2, comma, x cannot equal 7. So let's write them up here. X cannot equal 7. X cannot equal plus and minus 2 from these two. And we already got that one. And this one, negative 3. Put them in a nice order there. So we can say negative 3 plus and minus 2, 7. The order really isn't a big deal. If you don't put them into an order, I'm okay with that as well. There you go.